Space has always been a mystery for us. With the current technology, so many things are still so far out in the unknown that it's impossible to know them right now. That is until the largest telescope in human history was created. The James Webb Space Telescope is here, and it will blow our minds for good. About this telescope. This telescope collaborates with NASA, the European Space Agency, the ESA, and the Canadian Space Agency. NASA involved around 300 universities, organizations, and companies across 29 states in the United States and 14 countries to produce this technological masterpiece. It will probe the entire cosmos, helping to reveal what our glorious space holds. It'll have such huge advantages over the Hubble telescope that it will look like a newbie when the JWST is finally functional. As for the dimensions of this telescope, its primary mirror measures 21.3 feet, whereas the sun shield measures 69.5 feet by 46.5 feet. The overall mass of this telescope is 6,500 kgs. As for the movement of this telescope, it will orbit the sun in a different Lagrange point, which will help this telescope stay in the same line with the Earth. It is also predicted that this telescope will take a month to travel 1,000,000 miles to its permanent resting spot. This spot will be made stable by the earlier mentioned Lagrange point. This honeycomb-shaped structure is 3 stories high and is the size of a tennis court. This telescope structure comprises of 18 small hexagonal mirrors made up of beryllium coated with gold that has been optimized for reflecting infrared light from the ends of the universe. Apart from this, the primary mirror backplane assembly and the deployable tower structure lift the telescope off the aircraft. 3 arms at the top come together into a ring where the secondary mirror resides. Imagery and instruments. Looking for the first glimpse of a star, the James Webb Space Telescope has its instruments powered up. The star made the central observation point, and that is the HD 84406, which is located 241 light-years from the Earth. The images of the star will be taken by the James Webb's near-infrared camera, the NIRCam, which will cool down first to its operational temperature, which is minus 244 degrees Fahrenheit. At the beginning of the picture snapping process, there will be 18 dedicated images, but at the end there will only be a single focused image left. The NIRCam will focus on HD 84406, whereas Webb's optics experts move the mirror segments in nanometer scale steps to create a perfectly smooth surface. This is expected to last until late April, only after which the individual science instruments fully begin training their eyes on objects in the near and distant universe. The first clear images expected to be released to the public, taken from the JWST, could be as early as late June or early July. The 3 remaining instruments involved in the imaging will be the mid-infrared instrument, the MIRI, which is already partially turned on during the telescope's month-long cruise towards its destination. As for the other 2 instruments, which are the near-infrared spectrograph, NIR-SPEC, and the fine guidance sensor, near-infrared imager, and slitless spectrograph, FGS, near-IS, the control teams have turned off the heaters that kept them warm during the cruise phase. These heaters allow these instruments to slowly release the trapped air inside of them to prevent condensation of water, along with the buildup of ice. As the NIRCam and MIRI have already begun to produce incredible images of stars and galaxies, spectrographs will provide further detailed info on the chemical composition of distant objects. All the working temperatures of these instruments are kept low. This is necessary because the air temperatures play a crucial role in giving the JWST its scientific capabilities more or less. They're designed to image the oldest stars and galaxies in the world that came to life in the universe hundreds of millions of years after the Big Bang. Due to the expansion of the universe, light that was emitted by these galaxies is visible only in the infrared wavelengths. Since infrared heat is heat, the dim signal wouldn't be noticeable if the telescope radiated warmth. Stunning imagery is going to be a norm from the JWST. When we receive the breathtaking images of space, that will be the time we can go on and appreciate the JWST for its work. We hope to see lots from it because the telescope should be good in its functionality and appearance. The HD 84406 will be in for a photography session if all goes well, and the JWST will have a good time as its images the star and others after it. As we get pictures of the new constellations in our skies, the thing that needs to be paid attention to is the increased focus. With 18 images being received at the start and 1 focused image at the end, there needs to be a quicker way to focus on these celestial bodies. There shouldn't be a need for 18 images to show up at first and then a single clear image that comes up. With fewer images of a single body, there will be more time to focus on other celestial bodies. what will it do? We are going right up to the edge of the observable universe with Webb, says Caitlin Casey, an assistant professor of astronomy at the University of Texas at Austin. And yeah, we're excited to see what's there. Originally supposed to be launched in 2010 and cost only $1 billion, this telescope ended up launching 11 years too late, and its price tag ballooned to around $10 billion. But as per many scientists and astronauts right now, the wait will finally be worth it when this telescope begins relaying its pictures. Compared to the Hubble telescope, the Webb will surpass it in more than one way. It's not only going to allow astronomers to look far out into space, but it's also going to search for the first stars and galaxies of the universe as this telescope goes back in time. This telescope will allow scientists to carry out studies of hundreds and thousands of exoplanets and even search for signs of life on these planets, given that there are any. The JWST is going to be an instrument that is going to give us so many answers. What we're going to get is a telescope that's about 100 times more powerful than Hubble, says Amber Strogan, an astrophysicist at NASA who works on the Webb. Improvement on the Hubble telescope. The JWST will be a significant upgrade on the Hubble telescope, which is why it will eventually end up replacing it. There are several reasons why this replacement is going to take place. The Hubble is the size of a school bus, whereas the Webb is more like a tennis court. This thing is enormous. Strogan says, Webb is by far the biggest telescope NASA has ever attempted to send into space. The size of the telescope isn't just what matters. A significant thing when it comes to telescopes is the curved mirror. You could sort of think of the telescopic mirror like a light bucket, Strogan says. The more light you can collect in this bucket, the fainter and further away things you can see in the universe. The measurement of the JWST were explained in this section. After the introduction, which amounts to more than 6 times the light collecting area, which is going to result in clearer and more refined images. The images that are going to come back to the JWST will be breathtaking. Thousands of galaxies were uncovered by Hubble, but the JWST is going to give us an even more significant number. That is a guarantee. What Webb will do is take the field and go even further, explains Caitlin Casey, an assistant professor of astronomy at the University of Texas at Austin. So the specks of light in the background of the Hubble deep field will brighten and become more detailed. We'll be able to see spiral arms, we'll be able to see structure, and then we'll get more specks of light even further in the past. We're seeing further back in time with Webb. With the JWST, astronomers such as Casey will be able to go back so far in time that they can spot the first stars and galaxies. How far is that? Well, the Big Bang. You've heard of it. That's far, but Webb can take us to 250 million years after the Big Bang, explains Casey, who has been approved to work with the Webb Space Telescope. With so much in store with this telescope, it will help us to go back to the start of time and witness what our universe was like back then. It isn't a time capsule, but certainly something along those lines. Who is to know what the potential of the James Webb Space Telescope is? Right now, we need to be patient to answer this question. Thank you for watching this video. Make sure to subscribe to the channel and give this video a thumbs up.